Hi everybody, my name is Rupa, working as Assistant Professor in Chevron Engineering College in the Department of Electrical and Electronics Engineering. And today's subject is renewable energy sources. In the topic is components of tidal power plant.
The following points should be noted, especially in connection with the tidal phenomenon. The first one is tides are periodical phenomenon. Okay, so these are periodically existing, but no two tides in cycle are alike. Okay, every tide will be unique. Since the relative positions of the, because as the relative positions of the sun and moon and the distances from the earth, these are continuously changing, these tides are also influenced accordingly to the changing of this sun and moon. Okay, so of the two high tides in a single day, one tide is higher than the other. Okay, if there exists two tides in a single day, there will be not unique, there will be some difference in the heights. Okay, so in any month, these tides on full moon and no moon days, these are particularly higher than the rest ones. So as these days, because at these days suns and moon's attraction acts in a directly additive manner, these both attraction acts and these pull the water up and tides will be occurring. So these are termed as, we had discussed that these are termed as spring tides. So in a year that the tides occur at the time of vernal and autumnal equinoxes will be even higher due to relative location of the sun and earth. Okay, so we discussed it before equinoxes. So at the time of these equinoxes, we will get higher tides than the compared to the other days. So the tidal range shown in the figure, it varies time to time. So generally a long mean value of R, it is designated as mean tidal range at any particular point. So this is the first point we have to note. And the second point is the mean tidal range varies from place to place. Okay, so the shape of the tidal cycle, it depends upon the interaction of the sea with the coastline. So where the coastline offers a resonating influence, the tidal ranges get accentuated, means accelerated, means high tides will be expecting at the other places, and the land may produce a dampering effect on the tidal phenomenon also. So for instance, in landlocked seas, the tidal phenomenon is always much subdued. Okay. So because of this interacting effect, the tidal range as well as the tidal range and the tidal period, these varies from place to place. So for example, if you consider the mean tidal range on the west coast of India is as high as 7 to 8 meters near the Gulf of Kutch, whereas it is only 1 meter or so or less near Kerala. Okay, so this is the example that it depends upon the place. So because we are getting at near the Gulf of Kutch, we are getting 7 to 8 meters of tidal range, whereas at Kerala it is only 1 meter. And Bay of Fundy, Kenda, it is having one of the largest tidal ranges in the world. It is having of 20 meters. The tidal range is of 20 meters height, whereas Adriatic Sea at the Zara has virtually static water with the range being only few centimeters. Okay, so in the total world, we are having the greatest tidal ranges at Bay of Fundy, Kenda of 20 meters height, and lowest is at Adriatic Sea at the Zara. Okay, it has only few centimeters of tidal ranges. So thus the tidal phenomenon is the unique feature of every coastline. And the third point we have to remember, note down is, in spite of their complexity, the tides are amenable to mathematical analysis. So as a result, exact time and water level for high tides as and low tides can be forecast with greater accuracy. Okay, these are easy for mathematical analysis. We can predict them mathematically easy. So these are the three types of nodes we have to consider while we are situating any tidal power plant or some hydropower plant depending upon the tides. So next, the components of tidal power plant. So there are three main components of tidal power plants. First one is power plant. Second one is the dam or barrage, that is called as low wall, to form a pool or basin. So a dam or barrage are constructed to form a pool or basin. And third main part is the sluice ways from the basins to the sea and vice versa. That means the gates from the basins to the sea and vice versa. Okay, so all we see now. First, if you coming to the power plants, the turbines, electric generators, and auxiliary equipments are the main equipments of the powerhouse. Okay, and second one, the function of the dam is to form a barrier between the sea and the basin, or between one basin and the other in case of multiple basins. So if you take only single basin type arrangement, it is the dam or barrage, it is the barrier between the sea and the basin. Suppose if you take two basins, it is the barrier between one basin and other basin. Okay, and third one, the sluice ways. These are nothing but gates. These are termed as sluice gates. So these sluice ways, these are used either to fill the basin during the high tides, or they are used for emptying the base during the low tides. So as per the operational requirements of the turbines and as per the operation requirements of the tidal power plant, these are open and closed. Okay, so these are termed as gate control devices. These sluiceways are termed as gate controlled devices. Okay, so it is generally convenient to have powerhouse as well as sluiceways in alignment with the dams. So these three are aligned in a proper way. So the design cycle may also provide for pumping between the basin and the sea in either directions. So from the basin to sea or sea to basin, either flow direction is available and it is possible to operate the tidal power plant by using a turbine. So if reversible pump turbines are provided, the pumping operation can be taken over at any time by the same machine only. Okay, so if you incorporate reversible pump turbines, it is possible for the operation for any flow of direction of water. Okay, so the modern turbines, these are very versatile that they can be used either as a turbine or a pumps in either direction of the flows. So in addition, tubular passages can also be used as sluiceways by locking the machine to the standstills. So as compared to the conventional plants before what we have planted, these however impose a great number of operations in tidal power plants. So for instance, these periodic opening and closing of the sluiceways of the tidal plant are about 730 times in a year. Okay, so in a period, the opening and closing of the gates of the tidal are about average is about 730 times in a year. So these are the components of tidal power plants. Now coming to the dam or barrage, each one we will describe briefly. So first one, coming to the dam or barrage. These dams and barrages, these are synonym terms, both are equal only. So barrage has been suggested as more accurate than the dam because for tidal power plants it has to withstand heads a fraction of structure's height and the stability problems are far more modest. Okay, so the problems which are encountered in the dam, these are overcome in the barrage. Okay, so that tidal power barriers, they have to resist waves whose shock can be severe and where pressure changes sites continuously. So these have to resist, these have to be rugged to support the water resistance. So as the barrage length adds also a price tag of the plant. This acts as a price tag of the plant because short barrages are preferred, because the cost will be increased to a such a level that it is occupying one fourth of the power plant. So since barrage length also adds to the price tag of the plant, two short barrages are preferred even if the basin size may have to be smaller as a result of site choice. So up to a height of 20 meters cost, up to a height of 20 meters cost, this cost will be proportional to the length. Okay, as it is not changed by the need to build a dam wall to withstand high electrostatic pressure. So when the elevation, if the limit exceeds 20 meters, the cost will be further increasing faster with the lengths. Okay, so most tidal power plants do not have heads exceeding 20 meters. All will be below 20 meters only. Okay, so this barrage needs to provide channels for the turbines in stressed or reinforced concretes. Okay, so this barrages has to provide channels. These provide channels for the turbines in reinforced concrete. So to build these channels, a temporary confidant is necessary, but it is now possible to build them on land. So these are build them on land, and these are made to float them to the site and sink them into the places. Okay, next, flatness. The flatness is required for a sea bottoms because sandy bottoms usually necessitate pilling. Okay, and there where sand or rock can bear the weight of the structure to be implanted, the bottom can be prepared and the structure will be placed on it and then accorded. So prefabrication concrete blocks are used as the core for larger barriers, and this avoids filled with rocks and concretes. Okay, so the prefabricated concrete blocks are taken, and these are filled with rocks or concrete, and remaining holes are filled with the sand, and the entire construction is then situated there. Okay, so this construction of the barrage usually will influence the tidal amplitude. This influences the tidal amplitudes also. So the construction will be very important. The barrage construction will be very important. So the construction, it modifies the effective length of the embayment or basin and its shape also. Okay, shape also will be considered. So particularly if the scheme involves supplementary spud dams or brings about relocation or disappearance of natural obstructions, as is foreseen in the several plans, this will be occurred in Rand's century. This has been occurred in Rand's century. Okay, this construction influence the resonance of the bay, and most bays are less than the resonant length of the tidal waves. If they are more above the resonant, if resonance length is reduced, the range will decrease. So if measures are taken to augment the resonance, tidal amplitude will be increased. Okay, and the tidal barrages require sites where there is sufficiently high tidal range. The minimum useful range around the 3 meters range is done. Okay. The best sites are to build a dam or barriers. The best site is a bay or estuaries. Sorry, estuaries. So, but water can also be impounded behind the blended reservoirs. These are built between 2 points on the same shorelines. So these can also be on the same shorelines. They can be built between the points of the same shorelines. So the precise design of the barrage and its modes of operation, these will be depending critically on the requirement of power, and these have to be carefully analyzed for the economics also. And the simplest and cheapest schemes are single barrage designs. These traps the water in the basin at high tides to generate on the ebb. Ebb means flow back of waters. Okay. So the more, if you go on for more than one, the complex will be increasing. Okay, so more complex schemes will involve generation of both ebb and flow tides, or the construction of secondary basin will permit water to be stored and discharged whenever desired. But this is complex somewhat. So this will provide more firm power on flexible basis. So this expertise is necessary to design and build such structures. These are available. And the location of the barrier, it is most important, because the energy available, it is related to the size of the basin and to the square of the tidal range. Okay, so the energy available is related to the size of the basin and square of the tidal range. The nearer it is built to the mouth of the estuary or bay, the larger the basin will be there, but the tidal ranges will be smaller here. And there should be a balance between the increased output and increased material requirements and construction costs also. So all have to be balanced. One is coming to the gates and locks. Okay, so these tidal power basins, these have to be filled and these have to be emptied always. So always filling and emptying will be done. So gates are opened regularly and frequently, but heads vary in height and on these are located. Heads means located in in a very height and on the side where they occur, which is not in the case with the conventional river projects. So these gates must be opened and closed rapidly, and this operation should use a minimum of power also. Okay, and leakage is tolerable for gates and barrages. It is to some extent only. Since we are dealing with seawater, corrosion problems are accurate. So corrosion problems will be occurring, and these has to be very successfully solved by the cathodic protection. Okay, because in this problem we cannot paint. There is no possibility of painting, because this will be erosions of the paint at the water frictions. There will be water frictions at the gate, so paint will not be possibly be it is not stuck to the gates. So for this problem we are solving this problem by replacing the gates with cathodic protection. So gate structures can be floated as modular units into the place. So if you observe in the existing plans, whatever already existed plans, we are seeing that there are vertical lift gates. Okay, so in the existing plants, vertical lift gates are used, and this vertical lift gates technology is ready to substitute with a series of flaps. Okay, so these operate by water pressures, and these flap gates are gates which are that are positioned so as to allow the water into the base, and these require no mechanical means of operations also. Okay, so if used, these are positioned in the case of molecular, sorry, if these are used, these are positioned in case of construction in the Sections, the sections is replaced by the sections of vertical lift gates. These are replaced by the flat gates. So these are in the sections. A section is then floated into that place. Okay, so these have to be built so that the adequate for the maximum tidal amplitude. We have to ensure the maximum tidal amplitude is there. So that's what in that way only they have to be designed and they have to be built. So a gate will be transferred into hydraulic load to the concrete structures in present conditions. Okay, so if this operation is to be rapid means continuously, and if though it is operated rapidly, this is efficient. Okay, and this should be ensured that gates must be open under the maximum differential head also. Okay, this has the great advantage as flat as possible the tidal basin face of the gates. Okay, so these flat gates allow in the direction of the sea to basin. Hence, the basin level will be rising well above the sea level as ebb flow area is far less than the flood flow area. Okay, so we will discuss these ebb flow areas and flood flow areas in next classes, further classes. Ebb means I already said that it is a flow back. Okay, ebbing means flowing back of tide. This is called as ebbing. Next, coming to the powerhouse, because of the small heads only are available, we are using large size turbines. Okay, so for small heads availability, we have to use large turbines. So large turbines are needed. So as we are using large turbines, we have to use large structure powerhouses. Okay, so both the French and Soviet operating plants use the bulb type of turbines. Okay, so instead of if you are using propeller type with reversible blades, these bulb type turbines have horizontal shaft coupled to the single generator. So the cost per installed kilowatt drops with the turbine size. So it should be carefully opted. And perhaps large turbines must be installed in the future for major tidal power plants. So next one is bulb group type. This is a RANS example. So this turbine, a bulb type turbine, it is an axial flow turbine, the bulb set. Okay, so this is resembling in appearance a small submarine. This will be appearing as a small submarine and it is made up of ogive shaped sheet steel. It is containing an alternator and a Kaplan turbine. So Kaplan turbine is one of the type of the turbine. So it is placed in a horizontal hydraulic duct. Okay, and entirely surrounded by the water. So that is entirely surrounded by the water. A shaft will be provided in communication with the engine room of the power plant. Outside a shaft will be emerged for the communication with the engine room of the power plant. So this set function as a turbine and as a pump. It regulates the flow in both directions of the flow. That means both directions means one direction is from pipe to reservoir, that is basin, reservoir, or we can call it as basin, dam, or we can call it as barrier. Okay, so these are the abbreviations we have to these are the synonyms we have to remember. Okay, so this set of function of a turbine will be allowing the will be regulating the flow in both directions from tide to reservoir and reservoir to tides. Okay, and the alternator which is taken in this bulb turbine, it is directly coupled to the turbine, to the Kaplan turbine, and it turns it at some pressure. Okay, so the turbine is here is Kaplan wheel. It is having 4 mobile blades and guide vanes. Okay, so this total group, alternator and Kaplan turbine, this group functioning as a turbine in the direct sense basin to the sea. And this will be furnishing power in reverse sea to basin direction also. So functioning, it is functioning as a pump in the direct sense. We can see in next diagram this one. So this is the schematic layout of tidal powerhouse. This is the main unit way. Okay, here this is the turbine. These are the prime mover runners, and this is the speed increaser, and to this turbine a generator is shafted. This is the generator. This is the transformer. This is the crane. This is the level at which the maximum operation is done, and this is the level at which the minimum operation is done. This is the trash rack. The trash in the water will be collected by the trash rack, and this is the flow of the water from the sea level, and this is the seaside, and this is the dam or the barrage. So this is intake gate. See, observe, this is the intake gate. So water will be flowing through the turbine. So there will be a rotating movement. So this mechanical movement is converted to the generator. It is transferred to the generator. This is the draft tube, nothing but this is the gate here to allow the water which is flowing from the turbine. These flows here after water will be flowing on through the turbine. These are collected here and sent away again to the basin side. So this is the schematic layout of tidal powerhouse. See, turbine, generator, speed increase of the turbine. This is the mechanical equipment gallery. This is the mechanical equipment gallery. And seawater from the dam. These are allowed to move on to the turbine whenever the gate will be opened. And when the seawater enters the turbine, it rotates. And this, after the rotation of the seawater, these are allowed to go into the basin sides. So these are the rim type turbines. So different turbines are under study in this. Usually mentioned, these are included shaft turbines, rim type turbines, or straight flow turbines. So in this, generator is attached peripherally on the turbine blades, and this arrangement is coupled by two turbines of conventional type, and these two turbines are coupled to one type of conventional type generator. And a hydraulic system is there in which up to 6 turbines are coupled to a hydrostatic pumps. Okay, so to drive the Pelton wheel, which in turn drives a high speed generator, these arrangements are done. Okay, so there is one main problem in this type of rim type turbines. The main problem in rim type turbine, in which the rotor surrounds the turbine runner. As the rim is carried by the runner blades, it is sealed between the stationary parts and the rotating rim. So this is only the disadvantage. So engineers who favor straight flow generators, again the bulk turbine generators, point out the lower inertia characteristics of the bulk type. So if you consider this point, this could lead to a problems during power system disturbances. Okay, so the designers of a new type which are presently designed in the modern systems, these are designed in a new type of straight flow units, put forth savings in civil works. Okay, so these are saving in the civil works, And in generator and auxiliary electrical equipment, because large units capacities will be dealing, we are dealing with large unit capacities, this bulk type unit for same head. So this will be possible. This is the rim type. Now we will see the operational methods of utilization of electrical tidal energy. So this is the operating method of utilization, how we utilize the tidal energy by different operation methods. So there are different operation methods, single, double, like that. In this single also we are having again different types. So depending upon the different types of operations, we are using this tidal power for various applications. So first, for the generation of electricity from water power, this requires there should be some difference in the levels of the water. That means levels means we hear in technical terms in this tidal power, or it is in the terms of water we are calling it as head. Okay, a level is called a head. Okay, so for the electrical generation, for the generation of electricity, there should be some difference in the levels between which the water will be flowing. Okay, so there should be two difference of levels. First one is higher, with the head with higher level and head with lower level. So if there is some level difference, we can use this level difference for the production of electricity. Okay, so a number of concepts they have been proposed for generating electricity. Okay, so first one, for utilizing this head, can be it can be produced by the rise and fall of the tides. Okay, so tides means nothing but they rise to some altitudes and they fall. So this is utilized by the head. Okay, so this rise and fall of the tides, these operate the hydraulic turbines. And the power generation from the tides, they involves flow between an artificial development basin and the sea. Okay, so a basin is developed artificially, so that is termed as one level, and sea is taken, this is in the other level. Okay, so this difference makes to produce our electricity. However, in order to have a more or less continuous generation, this basic system can be elaborated into two basins. Okay. For satisfactory operations, actually for single basin we can use, but for moderate and for satisfactory operations we can use two or more basins. Okay, so accordingly we can distinguish the following types of arrangements into two types. First one is single basin arrangement and second one is double basin arrangement. Okay, so single schemes, these generate power only intermittently. Intermittent power is generated in this single basin because we cannot expect the tides. We can expect the tides, but the tides rise level is low, and the operation is also low, so we can get only intermittent power from this single basin. But if you want to generate a continuous power, we have to opt for the double basin generator only. Okay, so which will be more advantageous than the single basin. This double is more advantageous, but the drawback only in the double basin is it is having civil work, more extensive civil works. Okay, so in the simplest, if you take a simplest double basin scheme, there must be a dam between each basin and the sea. This is the first dam we have been considered. This is single basin, and other dam is taken between the basins, two basins containing the powerhouse. Okay, so first basin will be in between the sea and first dam will be in between the basin and the sea, and also will be
The dam will be located between the basins containing the powerhouse. So one basin is maintained always at the lower levels than the other. So as we are having two basins, one basin will be at higher level and one basin will be at lower level. So this lower reservoir, this empties at low tides. Okay, so this will get emptied. That means water will be flow out at the time of low tide, and the upper reservoir it is replenished by the high tides. Okay, so if the generating capacity is to be too large, the reservoirs must be also large. Okay, so this means dam should be dam will be long. This is the operational methods of utilization of electrical tidal power. Now we will see the basin arrangements. First one. So this is the first one, single basin arrangements. This is the simplest way to generate tidal power, and it is to use a single basin with a retaining dam in the following manners. If you follow this, we can use this single basin arrangement safely. So in this single basin arrangement, there is only one basin. So that's why it is the name existing single basin arrangement. Okay, so only one basin is arranged here. This will be interacting with the sea. This one basin will be interacting with the sea. So there are two, these two are the basin and the sea are separated by a dam, or we can call it as barrage. Okay, so and the flow between them is through sluiceways. Okay, sluice means nothing but gateways. Okay, sluice means nothing but gate, and the flow is between gateways, and these are located along the dam. Okay, so whatever along the dam means wherever the dam exists, there will be some sluice gates in between, and by using the sluice gates, we can operate the fall into the power plants. Okay, so the potential head it is provided by the rise, and it is the water in the potential head. These are occupied by the rise and fall of the tidal water levels. Okay, so this will be accomplished by blocking the mouth of the long